It began not with a roar of thunder, not with fire or fury, but with a whisper, a breath. A breath so small, so invisible, it would change everything that ever lived. Millions of years before the first dinosaurs, before forests or oceans as we know them, Earth was a toxic world, a planet wrapped in poisonous gases, glowing orange skies, and lifeless seas. But somewhere, deep in those alien waters, something tiny stirred, single-celled organisms, fragile, unseen, unstoppable, began to do something no creature had ever done before. They took in sunlight and exhaled a miracle, oxygen. It was the greatest chemical revolution in history and the deadliest, because the very gas that gives us life was poison to nearly every living thing that existed then. The skies began to change color. The oceans turned to rust. Entire species suffocated as the air itself transformed. The planet was being remade by creatures smaller than dust, rewriting the future of life, one breath at a time. This was not evolution, it was revolution. And from this apocalypse, the foundation of life as we know it would rise. Tone shift slightly brighter, cinematic lift. So if you think humanity changed the world, wait until you meet the first beings that nearly destroyed it just by breathing. Before we dive deep into this breathtaking moment in Earth's history, hit that subscribe, like, and drop your thoughts below. Because the story we're about to uncover isn't just science. It's the greatest drama this planet has ever seen. Earth long before humans, long before animals, even long before the first green leaf, was a completely alien world. Imagine a sky not blue, but hazy, orange, the air thick, choking, and deadly, the seas dark, metallic, and simmering with gases that would burn your lungs in a heartbeat. No oxygen, no ozone, no life as we know it, and yet this was home. This was the Earth of 5 billion years ago, a world on the edge of creation, waiting for a spark that would change everything. Back then, the planet's atmosphere was a poisonous cocktail of methane, ammonia, hydrogen sulfide, and carbon dioxide. Volcanic eruptions belched smoke across the skies, acid rain hissed as it fell into newborn oceans, and lightning storms tore across the horizon day and night. The sun burned dimmer, the days were shorter, and the moon hung closer and larger in the sky. It was a planet young and angry, a boiling sphere of chaos, but even in that madness, life had already taken hold. It was not the life we recognize today. There were no trees, no fish, no insects, no birds. Life was microscopic, tiny, single-celled creatures drifting in oceans, clinging to survival in a world of extremes. These primitive organisms were known as anaerobe life forms that thrived without oxygen, because to them, oxygen was a toxin. To an anaerobe, oxygen was death. It destroyed the delicate chemistry that kept their tiny bodies alive. They lived instead by feeding on sulfur and methane, drawing energy from volcanic vents and chemical reactions. Deep in the sea, theirs was a hidden world, silent and ancient, ruled by microbes in the dark. For millions of years, that's how Earth remained quietly pulsing with invisible life beneath toxic skies. But somewhere, in shallow waters bathed in sunlight, something extraordinary began to happen. A few strange microbes, perhaps by accident, perhaps by evolution's blind design, learned a new trick. Instead of using sulfur or methane, they learned to use sunlight itself to make food. They were the first photosynthetic bacteria, and they changed the rules of life forever. These tiny architects of the future were cyanobacteria, often called blue-green algae. They were small, simple, and countless. And with each ray of sunlight they absorbed, they performed a miracle. They split water molecules apart, using the hydrogen to make sugars and releasing the leftover oxygen as waste. To them, it was nothing more than chemistry, but in truth, it was the single most important event in the history of life. At first, the oxygen they produced didn't reach the air. It reacted with the iron dissolved in the oceans, turning the seas a deep, rusty red. Layer by layer, iron oxide, what we call rust, settled onto the ocean floor, forming massive iron deposits that still exist today. But the cyanobacteria didn't stop. They multiplied, covering vast areas of the ocean's surface in mats of greenish slime, breathing out more and more oxygen every second. For millions of years, they transformed the chemistry of the entire planet, molecule by molecule, and then the balance tipped. Iron in the oceans was used up. The oxygen had nowhere else to go. It began to leak into the atmosphere. Slowly, invisibly, the poison began to spread. For the first time in history, the air itself began to change. The sky, once orange and murky, began to clear. Sunlight shone brighter, scattering blue across the heavens. The transformation had begun. But for most life, it was not salvation, it was doom. As oxygen levels rose, the anaerobic organisms that once ruled the earth began to die off. They couldn't survive in this new world. Their very breath became their executioner. Entire ecosystems collapsed. It was a mass extinction on a scale the world had never known, wiping out nearly all existing life. The planet itself groaned under the weight of its own evolution. The very process that created new possibilities also destroyed the old ones. It was the first great extinction. A silent genocide carried out by creatures so small they couldn't be seen, reshaping the destiny of an entire planet. But within this devastation lay the blueprint for everything to come. Oxygen, deadly to the old world, was the foundation of the new one. It created the ozone layer, shielding the surface from radiation. It gave birth to the chemistry that allowed complex cells to evolve. It turned a toxic, alien planet into a world capable of breathing, growing, and thinking. Without that ancient apocalypse, without that invisible revolution, there would be no trees, no animals, no humans. There would be no us. And to think, it all began with a single breath, in the endless stillness of ancient Earth's oceans, long before eyes had ever opened or fins had ever sliced through the water. Something astonishing began to stir, something so small it could fit on the head of a pin, yet powerful enough to reshape the fate of an entire planet. The seas of that time were dark, heavy with minerals, and simmering beneath a dim orange sky. Lightning cracked across horizons of vapor and ash. Volcanoes spewed molten rock and gas, filling the air with poisons and the oceans with metals. Life existed, yes, but it was fragile, microscopic, and hidden in the shadows of hydrothermal vents and chemical soups. In this world of primal chaos, one kind of organism discovered a secret that would change everything: how to trap the light of the sun. These creatures were the Cyanobacteria, tiny architects of destiny and the planet's first true chemists. They were ancient, humble, and silent, but their discovery marked the birth of photosynthesis. With no eyes to see the light and no mind to understand it, they nevertheless learned how to use sunlight to make food, and in doing so, they created something the Earth had never seen before: oxygen. Imagine these cyanobacteria floating across shallow seas, forming vast, slimy colonies called stromatolites. They looked like alien carpets, greenish, blue layers stacked like ancient pancakes beneath the waves. To the untrained eye, they might seem lifeless, but they were bustling with microscopic activity, billions of cells breathing, dividing, and transforming sunlight into chemical energy. Every ray of light that struck them was captured, stored, and turned into the foundation of life's next chapter. But their work came with a consequence. In splitting water molecules during photosynthesis, they released oxygen, a waste product to them, but a poison to almost every other creature on Earth at that time. The seas, rich in dissolved iron, began to react with this new gas. Iron turned to rust, sinking to the ocean floor and forming massive bands of red and brown rock that we still find today, silent monuments to the first breath of life. Over millions of years, these cyanobacteria spread across the globe. They conquered every shallow bay, every sunlit lagoon, every stretch of coastal water. The Earth's surface shimmered with their living mats. With every sunrise, they exhaled invisible clouds of oxygen, little by little filling the seas and skies with a gas no one yet needed, but one day everything would depend on. At first, oxygen couldn't escape the oceans. It was trapped, bound to minerals, locked away in chemical reactions that painted the seafloor in rust-colored stone. But there was too much of it, too much for the ocean alone to contain. Slowly, quietly, oxygen began to leak upward, bubbling into the air, spreading through the atmosphere. The transformation of Earth had begun, though no creature alive understood what was happening. The rise of cyanobacteria was a quiet revolution, one that no one witnessed, but every living thing since owes its existence to. They were the first life forms to capture sunlight directly, to turn it into usable energy, and to release oxygen freely. Their gift and their curse was to alter the chemistry of the entire planet. What they began was not simply survival, it was planetary engineering, and yet, for all their greatness, cyanobacteria were not aware of their power. They did not know they were creating the future. To them, photosynthesis was nothing more than a means of existence, but to Earth it was a moment of creation, the spark of transformation. The skies that had once glowed orange with methane haze began to fade into pale blue. Sunlight reached the surface with new clarity. The air, once suffocating, became cleaner, thinner, breathable. As the oxygen continued to rise, it became a double-edged sword. It killed off most of the planet's anaerobic life organisms that had thrived in the old world of poison and shadow. It was the first mass extinction, a biological purge written in air and fire. But while the old world died, the new one was being born. Oxygen would soon make possible complex cells, animal bodies, and thinking minds. The cyanobacteria, in their simplicity, accomplished something no empire, no species, no civilization ever would again. They transformed an entire planet. They turned lifeless chemistry into the breath of the future. Without them, there would be no forests to sway in the wind, no oceans of fish, no humans to gaze at the stars and wonder where it all began, and to this day, billions of years later, their descendants still live among us in every lake, every ocean, every drop of water that glows green under the sun. They are the oldest survivors. The first engineers of life and the silent ancestors of every living thing that breathes. The change began quietly, invisibly, like a whisper beneath the waves. Oxygen, once a rare trace gas bound up in rocks and water, was beginning to spill freely into the atmosphere. What started as a slow chemical drift soon became a planetary upheaval. The tiny cyanobacteria that had been producing it for millions of years had no idea what they had unleashed. To them, oxygen was just a waste product, something to exhale and forget. But to the rest of the planet, it was poison. In the beginning, oceans bore the first scars of this new chemistry. They were once greenish, murky, and rich with dissolved iron. But oxygen reacted violently with that iron, transforming the seas into colossal vats of rust. Over time, layer upon layer of reddish sediment drifted down to the seafloor, forming massive iron deposits, banded iron formations that still lie buried within Earth's crust. These rocks are the fossilized evidence of the moment our world began to change. As oxygen levels climbed, the balance of life tilted toward catastrophe. The organisms that had thrived for billions of years, anaerobic microbes that could not tolerate oxygen, found themselves trapped in a world that was suddenly toxic. Their enzymes broke down, their cell walls corroded, and their chemistry turned against them. What was once their paradise became their graveyard. Across the planet, invisible ecosystems began to collapse. Entire oceans became killing fields. Microbial colonies that had survived since the dawn of time suffocated as oxygen seeped through their waters. The surface layers of the sea became chemical battle zones where oxygen and methane waged war for dominance. Methane, once primary greenhouse gas keeping Earth warm, was consumed by the rising oxygen, turning into carbon dioxide and water. As methane dwindled, so did the planet's heat and the air began to cool. Death toll was unimaginable, though no creature had eyes to see it. It was a silent apocalypse, a mass extinction so complete that it erased nearly all life forms that had existed up to that point. The irony of it all was breathtaking. The first great extinction was not caused by fire or ice or impact, but by life itself, by the smallest beings imaginable. The killers were microbes, and their weapon was air. Yet amid this destruction, something new was being born. Oxygen, though deadly to the old world, was the spark for something extraordinary. It made energy production vastly more efficient. For the first time, cells could extract enormous power from the same food. Oxygen-based metabolism produced nearly 20 times more energy than anaerobic respiration. That meant that life could grow larger, more complex, and more active than ever before. Evolution had been handed a new tool, the most potent source of biological energy in existence. But before that future could unfold, Earth had to endure its transformation. As oxygen filled the sky, it reacted with gases that had once trapped the planet's warmth. Without methane's greenhouse effect, global temperatures plummeted. Ice began to spread from the poles toward the equator. Within a few million years, the Earth may have frozen almost entirely, locked in what scientists call Snowball Earth. Imagine it, a planet of ice from horizon to horizon, oceans sealed under frozen shells, continents buried beneath endless white. Volcanoes alone kept the world from freezing solid, belching carbon dioxide into the air, building up enough heat to eventually melt the ice again. When that thaw came, it unleashed torrents of water, floods of minerals, and a newly oxygenated ocean. The world that emerged was clean, blue, and ready for the next chapter of life. The event is now known as the Great Oxidation Event, or, more dramatically, the Oxygen Catastrophe. It was both apocalypse and creation. It destroyed almost everything that had been, but it made possible everything that would ever be. It sculpted the atmosphere we breathe, painted the sky its brilliant blue, and set the stage for complex life. Those ancient microbial architects, unknowingly, had reshaped the destiny of the planet. They had brought death to one world and life to another. From their unseen labor came the breath of every creature that would ever live, from trilobites to dinosaurs to humans. And so, in the long silence of deep time, Earth took its first living breath, and never exhaled again. For the first 2 billion years of Earth's history, the sky was not the color we know today. It was not blue. It glowed a dull orange, hazy with methane and carbon dioxide, veiled by a dense chemical fog that scattered sunlight into eerie shades of red and gold. The air was thick and heavy, and the world beneath it was dim. But then, slowly, something miraculous began to happen. The change was not sudden. It took millions of years, an invisible transformation, molecule by molecule, until the heavens themselves were reborn. As oxygen began to seep into the atmosphere, a new kind of chemistry emerged. The gases that had once painted the sky in toxic hues started to vanish. Methane, one of the key ingredients that made the sky orange, reacted violently with the rising oxygen, forming carbon dioxide and water vapor. Each reaction stripped away a layer of the ancient haze, letting more sunlight pierce through. For the first time in the history of the planet, the air began to clear. Imagine standing on a shore, if such a thing had existed back then, and watching as the color of the world changed. The dim, reddish light faded, the horizon sharpened, the sun, once hidden behind veils of gas, began to blaze through the thinning air. The light grew whiter, cleaner, stronger, and as it scattered off the molecules of oxygen and nitrogen, the sky slowly transformed into that deep, endless blue that we see every day. The world was revealing its true color for the first time, but this transformation was more than just visual beauty. It was an atmospheric revolution. As oxygen levels climbed, something else remarkable occurred high above the Earth's surface. In the upper layers of the atmosphere, sunlight began to strike oxygen molecules, splitting them apart into individual atoms. Some of these atoms quickly rejoined in groups of 3, forming ozone O3. This thin, invisible layer of ozone began to act as a shield, blocking deadly ultraviolet radiation from the sun. Before the ozone layer formed, Earth's surface was a place of lethal radiation. Any organism that dared to live near the surface risked being burned by invisible rays. But as the ozone built up, it absorbed those rays, softening the sunlight that reached the ground. The planet became safer for life, setting the stage for evolution to step out of the ocean depths and into the light. The color of the sky was not merely a change of appearance, it was a signal that the Earth had been remade. It marked the moment when the planet's atmosphere shifted from an alien, suffocating shroud into a breathable cradle of life. For the first time, sunlight could pour down freely onto the oceans, feeding the cyanobacteria that had started it all, and energizing a biosphere ready for expansion. The oceans themselves mirrored the transformation. They were no longer iron, rich and brownish red, but clearer, greener, and alive with light. Sunbeams could now reach deeper into the water, driving more photosynthesis, creating a feedback loop of life and oxygen. The same process that had poisoned one world was now nurturing another, and as the atmosphere stabilized, weather began to change too. Chemistry of clouds shifted, the climate cooled, and rainfall patterns transformed. The planet was breathing differently, literally and figuratively. Storms carried new energy, lightning cracked through thinner air, and the rhythm of the planet began to resemble the one we know today. The transformation of the sky into blue and the formation of the ozone layer were cosmic milestones events that would make complex life not only possible but inevitable. The blue sky was a promise, a sign that the Earth was ready to host something more than microbes and mats of algae. It was a signal, written in color, that the planet had matured, its chaotic youth behind it. Billions of years later, that same blue dome would become one of the most familiar and comforting sights to humankind. Poets would write about it, children would stare up at it, explorers would cross oceans guided by it. But beneath its beauty lies a story of death and rebirth. A reminder that the color of our sky is painted with the breath of long, dead bacteria. The air we breathe, the light we see, and the calm blue above us are all gifts from that ancient chemical revolution. It was the first time the world could truly shine. What had once been a planet of fire, haze, and poison became a world of light, air, and promise. The blue sky was Earth's first declaration that life had conquered the chaos, and that it would never fade back into shadow again. The Earth had changed utterly and completely. Oxygen had flooded the atmosphere, the skies had turned blue, and for a brief shining moment, the world seemed alive in a way it had never been before. But the balance of nature is fragile, and the same transformation that gave birth to breathable air would soon send the planet into one of the greatest deep freezes in its history. The stage was set for an unimaginable catastrophe, a time when the world itself would become a frozen marble drifting through the dark, known today as Snowball Earth. It began quietly, almost imperceptibly. As oxygen spread through the air, it reacted with methane, one of the strongest greenhouse gases that had long kept the planet warm. Methane had been abundant, pouring from volcanoes and bubbling up from the oceans, trapping the sun's heat in the atmosphere. But oxygen destroyed it, turning it into carbon dioxide and water vapor, both far less effective at holding warmth. The greenhouse blanket that had kept the young Earth cozy was suddenly torn away. Temperatures began to drop, the seas cooled, ice crept slowly outward from the poles, reaching into regions that had never known frost. What began as a gradual cooling spiraled into something far worse. As the planet grew colder, more ice formed. The ice, in turn, reflected sunlight back into space, preventing the surface from warming. The more the Earth froze, the colder it became. It was a runaway loop, a death spiral of ice and light. Before long, the oceans began to freeze over. Sheets of ice spread across the continents, glittering in the pale sunlight. Storms howled over a silent world. From pole to equator, glaciers advanced, grinding rock into dust. Entire mountain ranges were swallowed beneath the ice. The seas, once teeming with cyanobacteria and primitive life, were trapped under a lid of frozen water, suffocating the ecosystems that had birthed the great oxidation in the first place. It is almost impossible to imagine what Earth looked like then. From space, it must have been breathtaking. An entire planet glazed in white, gleaming like a mirror against the blackness of the universe, but on the surface it was a world of desolation. The air was thin and sharp, the sunlight dim and distant. Beneath the ice, life clung desperately to the last traces of warmth, huddled around volcanic vents and deep sea fissures where heat and chemicals still flowed from Earth's molten heart. For millions of years, this frozen stillness endured. Earth's atmosphere was trapped in a fragile balance between death and survival. Volcanoes continued to erupt beneath the ice, belching out carbon dioxide, but it built up slowly. The gases couldn't escape quickly enough to warm the planet, yet over eons they began to thicken the atmosphere once more. Deep below the frozen surface, the planet was preparing for a rebirth. Eventually, the tipping point came. As volcanic emissions accumulated, carbon dioxide reached levels high enough to trigger a greenhouse effect strong enough to fight back against the endless winter. The ice began to melt. At first, it was subtle, a trickle of water here, a patch of open ocean there. But once again, Earth's feedback loops took over. Dark ocean water absorbed sunlight where ice had once reflected it. More heat meant more melting meant more heat. The frozen world began to thaw. When the ice finally retreated, the planet roared back to life with unimaginable force. Rivers of meltwater surged across continents, carving valleys and carrying minerals into the oceans. The seas, enriched with nutrients, exploded with microscopic life. Oxygen once again surged. The world had been purified, cleansed by catastrophe, and ready for something new. What had nearly killed the planet had also prepared it for its next chapter. The extreme cold had reshaped the continents, redistributed minerals, and filled the oceans with the raw ingredients for evolution. When the Ice Age ended, Earth emerged changed, richer, cleaner, and more fertile. The conditions were set for the next great leap, the rise of complex multicellular organisms. The great oxygenation had sparked the first mass extinction. Snowball Earth had nearly erased everything that remained, and yet, from this double disaster came renewal. The planet's first great winter had transformed it into a world capable of sustaining complex life. The silence of the frozen ages gave way to the songs of new creation, the birth of life as we know it. It is one of nature's cruelest and most beautiful paradoxes. The same forces that bring death also forge the path for life. In freezing the Earth, oxygen had tested the limits of existence, and in thawing it, evolution found its next breath. The world had survived its greatest trial. The long frozen silence of Snowball Earth had ended, and from the thawing ice came a rebirth so profound it reshaped the very definition of life itself. The planet, once locked beneath miles of frozen oceans, now glittered with liquid blue again. Warmth returned. Volcanoes breathed steam into the air. Rains fell upon naked rock, and rivers carried minerals back to the sea. The Earth had been purified, stripped of its old forms, and made ready for the next great chapter. The rise of Complex life, oxygen, once a deadly poison, had now become the engine of existence. The atmosphere was rich enough to fuel new chemical possibilities. For billions of years, life had been simple, tiny cells drifting alone, dividing endlessly, living and dying in microscopic anonymity. But now, in this rejuvenated world, something extraordinary began to occur. Cells started to cooperate. They joined together, forming communities, sharing energy, building bodies. What had been lonely and limited became united and limitless. This was the dawn of complexity. The first multicellular organisms emerged, delicate and strange, their translucent forms swaying gently in the ancient seas. They were soft, bodied, almost ghost-like, yet within them pulsed the rhythm of something entirely new. Organization. Different cells began to take on different roles, some specialized in movement, others in feeding, others in protection. For the first time in history, life had structure. It had purpose, it had form. Oxygen made it possible. The new gas allowed living cells to extract far more energy from food than ever before. With that energy came power, the power to grow larger, to think faster, to evolve. The oceans, once dominated by microbial mats, now shimmered with new shapes. Sponges, jello-like creatures, and early worms began to populate the seafloor. These were the first animals, primitive, simple, but alive in ways their ancestors could never have imagined. The chemistry of the world changed to accommodate them. As life grew in complexity, oxygen was consumed and replenished in an endless, self-sustaining cycle. The planet had finally achieved balance. The blue skies overhead were not just the color of atmosphere. They were the reflection of a living, breathing world, and yet the echoes of the past still lingered. The cyanobacteria that had sparked the great oxidation were still there, still performing photosynthesis, still feeding the cycle of life. They had outlasted extinction, ice, and fire. Their legacy was now written into the DNA of every living thing. In a sense, the microbes that nearly destroyed the world had become its eternal guardians. The rise of complex life was not just an evolutionary milestone. It was a miracle of endurance. It was the universe learning to build complexity from chaos. The first cells that joined together had no concept of what they were creating, yet their cooperation became the foundation for everything that would follow. Fish, forests, dinosaurs, humans, every heartbeat, every breath, every thought traces its origin back to that moment in the deep sea when life decided to work together rather than alone. The oceans, once empty and silent, now shimmered with movement. Tiny creatures drifted through the currents, feeding, dividing, evolving. The seeds of eyes, bones, and brains were being written in their genetic code. The story of life had entered a new act, an age of diversity, adaptation, and wonder. Earth had been born in fire, remade in ice, and reborn in oxygen. Now it was alive in every sense of the word. The same force that had once wiped out almost all existence had now become the reason for every living breath. From the chaos of destruction came the elegance of creation. From the ashes of extinction came evolution. So if you followed this far, if you witnessed the violent birth of our planet, the fury of the oxygen apocalypse, the freezing stillness of Snowball Earth, and now the shimmering dawn of life, know that the story has only just begun. Backhand index pointing right. If you haven't watched the previous episode, Snowball Earth, the planet that froze solid, the link is in the bio. Go back and witness how Earth turned into an icy world before this miraculous rebirth, because next time we travel into a new era, one of explosion, power, and imagination. Our next topic, the Cambrian explosion, life's Big Bang. It's the moment when evolution goes wild. When life bursts into countless forms, when eyes first open, predators first hunt, and the oceans become a battlefield of creation, stay with us. The story of history before humans is only getting started.